Okay, I want to look at first here, this is RT3 lesson 1. We're going to talk about sine, cosine, and tangent. Has anybody heard of sine, cosine, tangent? You've heard of it? Did you cover it at all in algebra?
Yeah, I kind
Nothing.
of remember it.
Maybe a little bit? All that sine, cosine, and tangent are ratios. So I want to look at two similar triangles for a moment. Let's go 4, 3, 5. Of course, this only works with right triangles. Okay, and I'm going to throw another right triangle that's similar. I'm going to call it 8, 6, and 10. Are these two triangles similar? Yeah, right? The side lengths are similar in their ratios. I'm going to introduce you to a Greek letter. It's called theta. It's not feta, cheese. It's not beta, it's theta, and I'll spell it out here in a moment. We're going to call that angle theta. It's just a way, it's like an X or a Y that labels an angle.
Why would they put like an X or a Y there?
Because X and Y are going to be used for side lengths. Yeah. So we use these Greek symbols. What's true about, well, the side across from it? Are they similar to each other? What's the side across from it? Opposite side? Where's the opposite side? Well, I would assume the opposite side is across from the angle. Are you with me? We're going to call this the opposite side. Opposite side. Okay. Notice that those have a 2-to-1 ratio. So do the adjacent sides. Oh, look at that, 4 to 8. Still a 2-to-1 ratio. We call that the adjacent side. I think we know how to spell opposite, so I didn't write it out. But I'm going to spell out adjacent because that's a word that maybe some don't know how to spell. What do you think we call this side here? Yeah, we call it the hypotenuse. That's the hypotenuse.
Like the 10 and the 5?
Like the 10 and the 5, they're called the hypotenuse. So we have 3 side lengths that we're going to reference in pretty much every problem. We're going to call them the opposite, adjacent, and hypotenuse. Okay, the opposite is always across from the angle. The adjacent is always right next to it, and the hypotenuse is always the longest side. Okay. All right, so let's look at these ratios real quick for a moment. What do you think is true about theta in both cases? What do you think is true about the measure of that angle? It's acute, correct? Do you think their measures are related?
Yeah.
Do you think they're similar? Well, what did we say 2 chapters ago when we said we had side, side, side similarity? What was true about their angles? They're the same, they're equal. Watch this, I'm going to give you a little visual. You ready? I'm going to take a triangle, and I'm going to turn it into a bigger triangle. Okay, so here's a triangle, right? I'm going to mark this angle right here, this little acute angle. I'm going to call it theta. Okay, I'm going to group that. What would happen if I made this larger? Do you think that angle would change in size? The ratio of the sides stayed the same, the angle measure, or the ratio of the sides changed, right? They got larger, but proportionally, right? The angle didn't change. So if 2 triangles are similar, their angles have not changed at all. So the angles are the same. Okay, let's move on to the next slide. It'll make more sense in a moment. Okay, like we just did on the last page, in a right triangle, we call these sides the opposite, adjacent, and hypotenuse. How come in the 2 diagrams we've changed the location of the opposite side? Because of the what, Wyatt? The X, right? We called it theta a moment ago, right? Once we change where that angle is, the opposite side and adjacent side change. What doesn't change? What else? hypotenuse, right? So I would call this maybe theta 1 and that theta 2 because those angles, their locations have changed. Okay. So now we have these three things called ratios: sine, cosine, and tangent ratio. Okay, how do you find the sine, cosine, and tangent ratio? You reference, first of all, the angle, and then you go from, and you find the two sides that are important. So for sine, sine is always opposite over hypotenuse. So, okay. Yeah, you know it. Sohcahtoa. Nick says Sohcahtoa, and he's right. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, that's how you get your ratios. You've probably heard it before. Maybe you haven't. Okay, now this was groundbreaking last year. Someone memorized Sohcahtoa and never knew what it meant. It actually has meaning here. What does the S in SO stand for? Sine is opposite over hypotenuse. They were like, oh, I thought we were just making something up and it rhymed, kind of. No. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent, opposite adjacent. Okay. All right. O is not hypotenuse. O is opposite. H is hypotenuse. A is adjacent. Okay, so for those of you at home that didn't get that and why I said equals or is and over, the sine of an angle equals opposite over hypotenuse. We just shorten it to look like that. So the cosine of an angle is adjacent side over the hypotenuse, which we write like this, shorthand. And likewise with tangent. The tangent of an angle will equal opposite over adjacent. We write TOA. Sohcahtoa. Say it 4 times out loud to your neighbor, and then we'll move on. All right, I'm gonna do this first example myself, and then you all are going to try the next one. Okay, watch first, please. Don't jump ahead. Okay, where is my angle? My angle is x in this case, and to be honest with you, we typically use theta, but I think in this chapter we use x and we use y. So Wyatt, there you go. You're going to use x and y for the angles for the time being. Okay, so here is my angle. Which of these sides would be the hypotenuse? 7. Good. That's my hypotenuse. Where is my opposite side? Opposite is 5. Opposite is 5. And the adjacent is 4. And the hypotenuse is always across from the 90, right? Always across from the 90.
Wait, I have a question.
So the sine, recall sine is opposite over hypotenuse. Which one goes on top? 5 goes on top. 7 goes on bottom. Cosine is adjacent to hypotenuse. Hypotenuse on the bottom. Adjacent is 4. Okay, tangent. Don't screw it up because it's happened before. Now I'm not using which side? Hypotenuse. Opposite side is 5. Adjacent side is 4. I'd like for you and a neighbor to do the second one together. Go. All right, so thanks to a couple of our super readers, Wyatt and Elsa. We got some correct answers here. Nick, do you have an observation? Oh, please tell me. Whew! Well, hold on. We don't want to cross multiply, but if I change the angle, it told me to switch my opposite adjacent, right? What happened? What happened with tangent? They flipped. Now, we said, what did we say about the hypotenuse? What happened to the hypotenuse? They never did what? They never changes. Chow. Chow. But what happened with the adjacent and hypotenuse? Wow. So who cares, right? Who cares? I care, because what it does is it allows us to find an angle measure. Okay, our calculator allows us to find an angle measure. Here's what I want you to do. Take out the old calculator. Okay, hey, I want you here on your calculator. Notice that I am in degree mode. If you have a little Casio, little scientific calculator, you're just going to have to sit there and watch for a moment, and I'll help you on the side. Okay, what I want to look at is this. We just looked at a triangle, right, that looked like this. Okay. I don't really care about the orientation here for a moment, but let's say that this was x. Okay, you with me? Yeah. Would you agree that the sine of x equals 3 over 5? Agreed? Okay, what's the cosine of x? Cosine of x is adjacent. So, no, adjacent hypotenuse, which would be 4 over 5. Okay, I'm going to show you something cool that your calculator can do. Do you know what that angle measure is? No, but your calculator does. Watch this. This is a really cool function of your calculator. We are going to find x by doing the inverse sine of 3/5. Inverse sine of 3/5. So if you have a graphing calculator, go back to your home screen.
Oh, I see it.
Okay, go back to your home screen, and you'll see right here the sine button has an inverse, sine to the -1. Okay, press second sine and type in 3/5. Why is this so dang large? I can't get to the numbers. The heck? There we go. Nope, I still need more. Goodness. Okay, maybe I gotta zoom out. Zoom out. Hey, what'd you get for an angle measure? Did you get 36.87 degrees? You should. Nice. Okay, now consider this for a moment. Do you agree that x... Hey, be quiet. Listen. Do you agree that the measure of angle x should be the same even if the cosine is 4/5? Right? Doesn't that apply to the same triangle? It applies to the same angle. So I'd like you to do the inverse cosine of 4/5 and see what you discover. Second, cosine. Oh, cosine. 4 divided by 5. Looky there. You get the same angle, right? The ratios all work. What should this equal? Inverse tangent of 3/4. No. It should be the same. Right? It should give you the exact same angle. In all cases, you get the same measure because they're the same triangle ratios. It finds you the angle measure in that way. Okay, now, we know an angle measure. It's 24 degrees. We don't know two of the side lengths, x and y. Okay, but if I were to look at this angle, we know this is the hypotenuse. What is 5? Adjacent. What is x? Opposite. So if I want to find, let's target x first. Let's find x. Let's target that as our first answer that we want to find. Do we want two variables in our answer, or in our problem? No. So which of the three, SOH, CAH, or TOA, do we not want to use?
We do not want to use the last one, TOA.
We don't want to use, well, that's actually the one we want to use.
We not want to use COA,
We don't want to use CA if we want to find x.
so we don't want to use SOH.
We don't want to use SO because that would involve x and y, right? We do want to use TOA. Right? What involves x? O. What involves x? These two involve x. We want to find x first. This involves x, and this involves x. Do you agree? The opposite side. Okay. What else does this involve? This involves x and what? And y. We don't want to use that one because it has two variables. What does CA involve? 5 and y. Okay, so we're going to use that to find y. What does TOA involve? X and 5. So we want to use this to find x. You understand?
But aren't you just going to end up with two variables in the end anyway?
No, watch. So if I write this out, we decided we're going to use tangent. So the tangent, just watch. The tangent of the angle, what is the angle? 24. The tangent of the angle equals opposite over adjacent. Opposite is x, and adjacent is 5. Guess what's coming next? We're going to cross multiply. So we're going to take x times 1, which is x, and 5 times the tangent of 24. Let me show you how that's going to work. Okay, let me get rid of all this. I'm going to take 5 times the tangent of 24. 5 times tan 24. Just like that. Okay, now your calculator does all of the ratios for you. There used to be hundreds of pages of ratios for different angles that someone figured out. Let's press enter, and that is going to give us x. X is about 2.23.
So what if they just give us like sin and then the number, you know what I mean?
Wyatt, let's not get ahead of it yet. Let's just do what we got here, and then we'll get to that, I'm sure, later. Okay, so if I want to find y, I'm going to use cosine, because cosine will use the 5 and the y. So the cosine of 24, how would I set up the right side of this equation? Adjacent, which is 5 over hypotenuse, which is y. I'm going to cross multiply that, and we're going to solve for y. Cosine.
So what would be like sine?
Opposite over hypotenuse. Cosine is adjacent over hypotenuse. So we're using the adjacent and hypotenuse here to solve for y. So when I cross multiply, I get y times the cosine of 24 equals 5.
Oh yeah, see.
You good? Okay, now what do I do to solve for y? Divide by cosine of 24. Let's try it. Let's find y. Five divided by cosine 24. Looks like 5.47. 5.47. Let's take a moment to analyze this here. And this is your first time through trig, you guys. It's okay if it doesn't. This is trigonometry. Trigonometry. Okay? We said that x was 2.3. That's that side length. We said this was 5.47. I want you to analyze this and just look at it. Does it make sense that y is the longest side? Yeah. Right? Does it make sense? Sure. Okay, that is right triangle trig using Sohcahtoa. Okay, if the cosine of A equals 3/5, okay, if the cosine of A equals 3/5, Okay, let's say here we are at A. How would I write a ratio for cosine of A in this triangle? It would equal what over what? What's the adjacent side in the triangle? Well, we know that the ratio is going to be 3 over 5, but in the triangle, now ignore that number. In the triangle, what is the cosine ratio? X over x plus 4. Does that take you back about 3 chapters?
Yeah.
This is the hypotenuse. This is the adjacent side, right? So I'm going to cross multiply. I'm going to distribute. I'm going to subtract. X equals 6. So this side right here equals 6, and this side right here equals what? 10, yeah, because x equals 6. Cool. The next slide I'm going to do just because I like trig, and because I want it on the video for the children on the web that are watching. The egg thing. Now that represents an angle, and it's called theta. If I draw a triangle like this and I put theta right there, if I said the sine is 5/13, you'd say, oh, opposite over hypotenuse, right? Could you figure out the third side? Using what theorem that rhymes with Pythagorean? Pythagorean. So this side, if you remember, although not drawn to scale, a 5, 12, 13 is a right triangle. What is it? Pythagorean triple, yeah, that. So let's see. We know the sine of theta equals 5/13. What would the cosine of theta equal? Ka. Cosine. Adjacent. Hypotenuse. What would the tangent equal? O opposite. Adjacent is 12. So just knowing 2 of the sides of a right triangle, I can find the third and then all 3 of the ratios. I found the answer. It said find the cosine. Done. Find the tangent. Done. Now if I wanted to find the angle, I could do the inverse of any one of those 3. They should all be the same. I like tangent the best. It's my favorite. So if I did the inverse tangent of 5/12, I could find the measure of theta, which is an angle. I'm going to do that right quick here. Inverse tangent of 5 divided by 12. Oh yeah, 22.62 degrees. So theta is 22.62 degrees. That's trig. Like, subscribe, comment below. Gains, we're still at 60 plus subscribers, 100th subscriber, $11 to GNC. Hallmarks on Schoology. Have a pleasant day.